Hello, students. One more thing before we begin formal data analysis. We need a bit of understanding on the types of studies that we'll be seeing and the types of analysis that we'll be doing before we actually get into the analysis itself. So I'll draw your attention to the introduction first. In research design and epidemiology, studies can be classified based on a few different things: the data types, the measurement times, how many observations are made per participant. So is there one observation per participant or multiple? Below, we'll see a breakdown of these study types along with the details about identifying exposure, outcomes, and the unit of time in each analysis. These are the key items that you'll need in each analysis to note. So you'll need to note the exposure, you'll need to note the outcome, and then finally the unit of time. So those are the three key aspects in study design that you'll need to know. Okay, now down to study types. So first we have cross-sectional studies, which are observational. We have observations per person, so a single type of observation per person. And the measures and exposures and outcome are at the same point in time. The exposure is assessed at the same time as the outcome, and the outcome is collected at the same time with the exposure. So for cross-sectional studies, it's a point in time. So if X here is the axis, cross-sectional will be a measurement at one point in time, at time one. Now, if you have repeated cross-sections, you can have time one, time two, you can have your cross-section reoccurring over time as often as need be. Pre-post studies, these are observational or experimental. We need at least one observation before and after an intervention or exposure. We are looking at the difference between the pre and the post measurement. The unit of time for pre-post, if there's multiple pre and multiple post tests, you can compute a unit value in time. Otherwise, a time between the pre and the post test is what you're looking at. Next, we have repeated measures, longitudinal studies. So these can be repeated over time. You can have multiple observations per person over time, and you can have differential numbers of time points per person. So we're measuring the same variables repeatedly over several points in time. The exposure can change over time or be constantly measured and can be assessed at each point in time or at the start. The outcome can be measured at multiple points in time. The unit of time is a specific interval, so it could be daily, weekly, monthly, annually, and so forth. Next, we'll look at case control studies. So case control studies are observational. They use a single observation for a retrospectively collected data point. You're going to compare, in a case control study, people with a case with an outcome that you're looking for to controls without the outcome, and look backwards to identify exposure. The exposure is assessed retrospectively for both cases and controls. The outcome contains the presence or absence of the condition, disease, defined as case or controls, and the unit of time is retrospective again, so it can be the portion of time that you're measuring. Cohort studies can have multiple observations per person or single observations per person. They follow a group over time to observe how exposures affects outcomes. The exposure is assessed at the beginning or during the study period, with the outcome measured over time as participants are followed. The unit of time is tied to where the observations are collected. So usually in usual care, it's collected as the patient seeks medical care. And then finally, RCT. We won't use a lot of RCT data in this class, or in fact, any, I don't think. So this is experimental. You're going to have multiple observations per at least one pre and post exposure. Participants are randomly assigned to an intervention or control group and followed over time. Measurements are at baseline and follow-up intervals, and it's a pre-specified set of unit of time. Here's your summary table where you can quickly refer to your data. Now, we've covered some study types, but now I want to speak a bit about the data types, and these will also inform what kind of analysis you can do. So you can have continuous data measured on an infinite scale. So we can also call this infinitely divisible. For example, age or an outcome of BMI. And for analysis, you can look at measures of central tendency, including mean, median. You can look at linear regression. You can display data with scatter plot, line chart, histograms, or box plots. You can use linear regression, random effects models for continuous data. So continuous data, very robust and a lot of accuracy with continuous data. So categorical data, it's with distinct categories. For example, yes, no responses. Example would be smoking status or disease presence or absence. The different kinds of categorical data, there's nominal, which has no natural order, and then there's ordinal, which has a natural order. You can use frequencies or mode to look at categorical data, and you can display categorical data using pie charts, bar charts, and contingency tables. We're not going to use pie charts in this class because pie charts are really not an optimal way to display data. You generally want to be using bar charts instead. And the analysis methods here, you can use logistic regressions, you can use odds ratios. Then there's interval data. So there's numeric data with meaningful intervals but no true zero, like temperature in Celsius. So interval can be like a Likert scale from like 1 to 3, 4 to 6, for example. Those are interval data. You can use histograms or line charts to graph interval data. And the final kind of data is ordinal, so that's ordered categories. So for example, stages of cancer, you can use median percentiles, box plots, or bar charts. Now, I've chosen to show you a nice summary table here. So your type of data will affect your measures of central tendency, your analysis method, your visualization method, and your outcome measurement. So it's really integral. When we start doing a data analysis in the following lectures, that the first thing we're going to do is to identify our data types, and we're going to let that inform what kind of analysis we can then do. I've quickly listed out what we're going to do in the course in terms of like what kind of analysis we'll do. So we're going to briefly, in a high level of detail, so not in really in depth, but a simple template analysis of each of these kinds of analysis. So we're going to look at logistic regression, linear regression, histogram, box plot, scatter plot, line chart, Poisson regression, random effects models, and time to event analysis. I'm wondering if I forgot anything. We might look at some hex plots as well. Those are fun, perhaps, if we get to it. But these are what we're focused on in terms of data products. And we're going to try and produce a simple yet effective version of each of those with the course data sets where applicable. And when we don't have course data sets, we'll use like toy data sets or template data sets to replicate. So in conclusion, your type of data, whether categorical, interval, ordinal, or continuous, will inform how you analyze the data and determine the appropriate analysis method. Also, your study type will inform what kind of analysis methods you need. Thank you.